Can artificial general intelligence, or AGI, truly grasp the intricacies of physical concepts? This question has intrigued researchers. The answer, it seems, is not as straightforward as we might hope. Take, for instance, the concept of a spaceship's gravitational maneuvering. Current AGI models, including language models and deep neural networks, often falter when tasked with comprehending such phenomena. Why is this so? These models tend to skim the surface, processing only the most apparent information about concepts like spaceships and gravity. They stumble when it comes to delving deeper, to the nitty-gritty, the fundamental understanding of how these concepts function in the physical world. This is a limitation, a stumbling block in our quest for a truly intelligent AI. So it appears AGI's understanding of physical concepts might be more superficial than we'd like. What sets the human brain apart from the animal brain in terms of cognitive capabilities? Well, we can turn to the philosophical musings of Henri Bergson for some insight. Bergson, a French philosopher, once drew a comparison between the cognitive abilities of humans and animals. His interpretation, later expounded by Gilles Deleuze, suggests a qualitative difference. It's not just about who has more of this or that cognitive ability. It's about the fundamental nature of these abilities. Consider a simple example. A dog might recognize its owner, understand basic commands, and even sense emotions. Yet it does not grasp the concept of tomorrow or contemplate the meaning of life. In contrast, the human brain can engage in abstract thinking, complex problem-solving, and introspection. The cognitive capabilities of humans are not just greater in degree, but different in kind. Now let's draw a parallel to artificial intelligence. Just like animals, AI models, particularly the deep neural networks and language models we see today, can perform specific tasks impressively well. They can recognize images, translate languages, even beat humans at complex games. But do they truly understand the concepts they deal with? Can they comprehend the deeper essence of language or the fundamental laws that govern physical phenomena? The answer, at least for now, is no. These models process surface-level information. They can infer patterns, but they can't infer meaning. They can't understand why a spaceship maneuvers a certain way in a gravitational field, or why a sentence means what it means. They lack the kind of understanding that comes naturally to humans. This is not to belittle the accomplishments of AI. Far from it. It's a testament to the complexity and depth of human cognition, a reminder of the challenges that lie ahead in our quest to build machines that can think like us. It seems the cognitive capabilities of the human brain are still a step ahead of AI. Can language in all its complexity be truly mastered by AI? Now that's a question that sparks a myriad of thoughts. Consider the Lutheran missionaries who used pidgin language. This simplified language, stripped of grammatical complexities and nuanced vocabulary, was used to bridge communication gaps. It served its purpose, but the question remains, can such a language convey complex ideas with the depth and richness of a native tongue? This scenario mirrors the struggles of artificial intelligence in understanding and replicating human language. Today's AI models can process language at a surface level akin to pidgin, but they struggle with the subtleties, the undercurrents of context, emotion, and cultural nuances. They can recognize words, yes, but can they truly understand them? Language is a tapestry woven from threads of history, culture, and personal experience. It's more than just syntax and semantics. It's a dance of connotations and denotations, of idioms and metaphors, of sarcasm and sincerity. It's a tool for expressing abstract thoughts, emotions, and philosophical concepts. So can a machine, devoid of personal experiences and cultural context, truly grasp the depth of human language? Can it understand that the phrase, "it's raining cats and dogs," has nothing to do with pets falling from the sky, or that break a leg is not a call for physical harm? Language, it seems, is one of the great hurdles for AI to overcome. How do different philosophical and educational approaches influence AI? When it comes to artificial general intelligence, or AGI, we can't overlook the potential impact of different philosophical and educational approaches. Think about it. Just as these schools of thought shape human cognition and interactions, they could also shape how AGI learns, thinks, and interacts. Take, for instance, the concept play workshops. These are based on an approach that encourages participants to explore, experiment, and engage with concepts in a playful and creative way. Now imagine if we used a similar approach to train AGI. Instead of feeding it with raw data, we could expose it to a variety of scenarios, encouraging it to experiment, learn from its mistakes, and develop its own understanding of concepts, just like humans do. Now let's consider Deleuze's theories, which advocate for a shift from a linear, hierarchical understanding of knowledge to a more interconnected, rhizomatic one. What if we applied this to AGI? It could potentially lead to a more nuanced, interconnected understanding of concepts, moving beyond the surface-level understanding that current AI models are limited to. But here's the question: how effective can AI be in these educational and philosophical contexts? Can it truly understand and replicate the depth and complexity of human cognition and interactions? Or will it always fall short, remaining a mere mimicry of human intelligence? The integration of AI into various contexts is a complex and intriguing matter. Can AI authentically replicate human interactions? A question that continues to baffle scientists and researchers alike. Despite their remarkable achievements, today's AI models still stumble when mimicking the depth and complexity of human interaction. You see, human interaction is not just about exchanging words or following a set of predefined rules. It's a dance, a symphony of subtle cues, emotions, and shared experiences, all intricately woven together. And this is where AI hits a wall. Yes, it can mimic our words, mimic our actions, but can it understand the emotional context behind a comforting hug or the shared joy of a hearty laugh? Can it grasp the nuances of our interactions, the unspoken words, the silent gestures? The answer for now is no. AI in its current state is like a skilled parrot, perfectly mimicking the words but missing the depth of meaning behind them. Human interaction remains a realm where AI has yet to make significant strides.